welcome to today's class. Today we want to write equilibrium expression. They say you should write the equilibrium expression for this following compound. Now let's start with the first one. The first one here you have AgBr solid. Remember you can write equilibrium for a reversible reaction forward and backward. So you are going to have Ag plus Br minus. Anything that is carrying charge is aqueous. So now if you want to write this, you write K. So basically KSP is equals to product by reactant. So that would be Ag plus times Br minus over AgBr. So beta of a natural substance is 1. So beta of AgBr is equals to 1. So if you multiply this one by this, you just have KSP is equals to, that is just Ag plus and Br minus. The same thing for number 2. For number 2, you have MgOH2. Remember, you write something like this. So I'm going to have Mg2 plus OH minus aqueous. So if you want to write this solubility product KSP, normally K is just equilibrium. So you're going to have product over reactant. That will be Mg2 plus times OH minus over MgOH2. You can now rewrite it like this. This one is equals to 1. So you can just write it as. So let me solve the third one. The third one you have, that is CaF2, calcium fluoride. Fluorine are the atomic, just like chlorine is -2, but if it is chloride, it's going to be -1. So calcium fluoride, you have calcium is Ca2 plus, fluoride is F minus. So that's why you have these two coming, that is CaF2. Now let's get back to this. So here you are going to have Ca2 plus F minus. This one is aqueous, solid rather. So we have the KSP is equals to, you now do Ca2 plus times F minus over CaF2. Alright, the last one we have PbCl2. I would have loved them to do the last one by themselves, but let me just quickly do it. So yeah, you're going to be having, that will be Pb2 plus Cl minus. So you have KSP is equals to Pb2 plus Cl minus over PbCl2. Now let me give you guys a law. I'll give you two laws. You study the law of mass action by Ridge and Ochberg, which says the rate of reaction is directly proportional to the active mass of the reacting substance. I get to now. So by the time we do that side, so we always have product over reactants. How to write equilibrium expression? We have a lot of K. We have K, KW, KSP, Ka. We have many K, but literally K is equilibrium. But when it is involving solid aqueous like solubility product that can dissolve, you use KSP. But just now K is for equilibrium expression. Now for this one here, I want us to look at this place here. There's something I need to explain about the molecularity becomes the order. We didn't check whether the equation was balanced. Here you have oxygen is 1. That is the next thing we are going to do now. For those ones that has number 1, number 2. Number 1, number 2. So let's quickly do that together. For number 2 here, magnesium is 1, magnesium is 1. Oxygen and hydrogen is 2, so 2 be here. I get now. So since you have 2 moles of hydroxide, the molecularity becomes the order raised to power 2. The same thing too for number 3, CaF2. Calcium is 1, calcium is 1. Fluorine is 2, so that will be 2F. So for this 2F here, I have F raised to power 2. the molecularity becomes the order. Order is the power. Then the last one, PB1. So yeah, I'm having 2Cl plus 2Cl. So these two comes here to become the power then. So that is how we solve questions like that.